It's really nice to see everyone here. My name is Maya Singh. I am going to be giving you all the rundown on the Inspector Gadget project today. Thank you so much for being here. I'm really honored to have the opportunity to talk at scale, and I want to give a huge shout out to all the volunteers, the staff, the awesome community members who make this event possible. So I think we should get that applause out of the way from the beginning. Yeah, thank you so much, everyone. It's like so nice to have so many members from the community in one place. So yeah, thank you all for being here. Alrighty, so I have a few goals for the presentation. By the end of the hour, I'd love for us all to have a high-level understanding of eBPF and its superpowers. Hopefully you'll have an understanding of Inspector Gadget and how it supercharges eBPF. We'll get into all of that. And fun. I hope everyone is engaged during this talk and you enjoy learning about these items. I have some small interactive portions throughout the talk to hopefully keep you all excited about Inspector Gadget and eBPF. Sound good? Yeah, okay. You guys will have to keep me honest. So here's our agenda, here's our roadmap that we'll be going through to work towards the goals that we set out at the beginning. I'll give a little background on myself. We'll do an intro to eBPF. It is what powers Inspector Gadget. And then we'll get into exactly what Inspector Gadget is, how you all can leverage it, and then the roadmap, which is the most exciting part to me, of course. What's next? Alrighty, so my name is Maya Singh. I'm a product manager at Microsoft working on the Inspector Gadget project. I joined the team late last year, but pictured here are two maintainers of the project who were there at the inception of Inspector Gadget. Mauricio is our technical lead, and Chris is our technical product manager, and many of the slides you'll see today have been repurposed from some of their previous talks, so I wanted to give them a shout out, and they have some great talks on YouTube too, so if you like what you hear today, you can find out more information from their awesome talks on YouTube as well. I will also call out that it was on the title slide, but Inspector Gadget is a CNCF Sandbox project, which I'm really excited about. And for those of you who were here for Alan's presentation previously, he showed his little observability grid with all of the different projects, and Inspector Gadget was one of those little squares, so it was really exciting to see that as even part of his project, his presentation earlier. So we're really excited to be very close to landing the core functionality of Inspector Gadget. However, I did want to call out ahead of time that some features are behind an experimental flag or in progress. So what you'll talk about, most of it is landed, but some things I'll mention are on the roadmap and actually very close to being landed. So we're really excited about that. But most importantly, that means we're really eager and excited to hear your feedback on the functionality and the user experience. So the beauty of open source and everything's still being in the works is that you all have a say into what's next and how things are created. So yeah, at the end you'll see the GitHub, the Slack, all of that good stuff, but since this is a sandbox project still being developed, all of that good stuff, you all have a say into what Inspector Gadget becomes. Alrighty, so this is the first interactive portion. If you guys have your phones, and I'll play along too, we can go to menti.com and type in these numbers. Are you guys able to read the numbers that are on the screen? It's, okay, cool. And I'll flip over to the poll. Sorry? Oh, no data. Yeah, I guess for those of you who are connected to the Wi-Fi, you can go to menti.com and go to 2209-6641 is the code. And I will flip over to the Menti, and we're going to create a word cloud, basically, of what comes to mind when you hear eBPF. Yeah, It's 2209, hang on, let me flip back, 6641. One. It's working for some people. This is exciting. Are you guys, oh, it's not, I don't know why it's not showing over there. Do I need to drag it over maybe? Let me see. Oh yeah, here we go. I'll show it to you guys this way. There we go. Now you all can see it too. Let me maximize it over here. Thanks for your patience. Yeah, and for those of you who are, there might be some people watching on YouTube too. Like this, hopefully this is a way to engage anyone who's watching online live. I think there's a live stream for this, right? Yeah. This is good. So we have Linux, kernel, observability, networking, Berkeley packet filter, fundamental packet filters. That's cool. So it seems like we have a pretty knowledgeable audience. So like, this is awesome observability. This is cool. Thank you for playing along. This is great. Magic, I love that. Whoever put that one. Awesome, deep inspection, safe networking. Okay, cool, this is great. I feel like you all have a like introductory sort of understanding of eBPF, so that's awesome. We'll do another high-level overview through this presentation to give you guys all further knowledge on eBPF. Let's see if I can come over here. Alrighty. Okay, let's go. Okay, thanks for doing the Menti poll. That was great. I really appreciated us working together to create that word cloud. So now we'll dive into what is eBPF. eBPF, like I mentioned earlier, is the technology that powers Inspektor Gadget. So I'm going to do a very short, high-level introduction to eBPF so that we can set the stage a bit. Ultimately, we like to say Inspektor Gadget supercharges eBPF and takes its existing superpowers to the next level. So it'll be good to understand those superpowers, which it seems like a lot of you already do, which is awesome to start out with. Cool. So eBPF is in-kernel bytecode runtime used for tracing, security, networking, that sort of thing. But what exactly does that even mean? Ultimately, eBPF allows for programs to be safely executed in the kernel. Since it's such a sensitive space, like, we're talking to the hardware essentially, we want to be able to understand what's happening in the kernel and even change what's going on there, but in a safe way. And eBPF allows us to do this in a performant manner. So eBPF brings flexibility to the kernel. What does that mean? That means we can see what's happening in the kernel, observability, that's the key thing that we're all here today for, and even change what's happening in the kernel, change the functionality without having to wait for a new kernel update. Working with the upstream maintainers and all of that stuff takes time, so we can use eBPF to actually see what's happening in the kernel and even change what's happening there. Additionally, it does have low strain from a performance perspective. It uses a just-in-time compiler approach, which ultimately results in low strain from a performance perspective. And most importantly, it won't crash your kernel. So that's sort of the most important part, I imagine. No one likes seeing the blue screen of death. But yeah, it works in a sandbox environment and runs through, eBPF programs run through a verifier to make sure that the programs are not going to crash your kernel. So now that I sort of mentioned that eBPF can be used for tracing, security, networking, and I wanted to give you all some examples of what exactly that means. When it comes to tracing, we can use eBPF to measure CPU usage, memory allocation, those types of things. And sort of a fun fact is that Android uses eBPF for traffic monitoring and accounting. So they basically use eBPF to understand how much CPU usage and memory usage apps on the Android OS are using, which I think is a cool application of eBPF. It can also be used for security in terms of whitelisting or blacklisting system calls. So from a security perspective, one example of this could be that you want to prevent a process from executing the execve system call. That system call is the one that is used for launching new programs, and sometimes it can be used to inject malware into the system, so ideally we would blacklist that. So we can use eBPF to intercept that execve system call and halt the execution of this process and prevent it from launching new programs. Definitely don't want malware on our system. And finally, networking. This is a pretty common application of eBPF. You all might have heard of the Cilium project. That's sort of one of the big projects that is using eBPF today. And that's they use eBPF primarily for networking. One example of this is that you can use it for firewall rules. So if you want to drop packets based on a certain condition, you can use eBPF to do that, like for malicious traffic, for example. Cool, so I'll go a little bit into how eBPF actually works. eBPF is event-driven, so that means that when a given event occurs, only then the eBPF programs are executed, and we use hooks to understand when these particular events are happening. So essentially, when the hooks are passed, that's when the event is occurring, and then that's when the eBPF programs are executed. So there are many, many different types of hooks. Some common ones as it relates to eBPF are K-probes. You'll definitely hear about those. Those are when a certain event happens in the kernel, like the execve syscall that I was just talking about. You could write an eBPF program to hook onto that and execute your eBPF program when that type of event occurs. There are also network devices and Linux security modules. These are different types of hooks that you can write your eBPF program to be executed when these particular events happen. Another sort of key piece of eBPF and how it works is the concept of eBPF maps. eBPF maps are the storage structure that lives in between the eBPF programs and your application, and that is in the user space. So essentially, your eBPF programs are generating a lot of useful data, sending it to this eBPF map, which then your applications can access using the BPF system call. So ultimately, if we're putting the whole picture together, we have our hooks that trigger the execution of the eBPF programs. The eBPF programs send that information to the eBPF maps, and then your application can get the information and data from the eBPF map using BPF syscall. Cool, so we spoke a lot about the superpowers that eBPF has. It has these capabilities. It brings flexibility to the kernel, it works in a performant way, and most importantly, it's safe. But with all those superpowers, it's sort of like Spider-Man, with great power comes great responsibility, and that writing eBPF is a big responsibility, and it has a steep learning curve, right? If we have all of these constraints, it does require a deep level of low-level systems troubleshooting, and it can be challenging to learn how to write within these constraints and build these eBPF programs. And additionally, eBPF has limited higher level context, meaning we can get a lot of valuable data from the kernel. That's what it's for. But when it comes to understanding the context of containers and Kubernetes, that higher level context is missing. So we did a quick overview of eBPF and how it works, and we know that in the kernel, it's event-driven, it gets us a lot of valuable data, it sends these events to the eBPF maps, but then what do we do with all of this data? It's super granular, there can be a lot of it, it doesn't necessarily have that higher level context around containers and Kubernetes that I mentioned earlier. So that's why we have the big question mark, what do we do with it as users in the user space and the application space? That's where Inspektor Gadget comes into play. So yeah, let's dive into what Inspektor Gadget really is. I like to think of Inspektor Gadget in three main buckets. First of all, it's a set of tools that we call gadgets that empower users to inspect Linux and Kubernetes systems using eBPF programs in an accessible way. It's also a framework, so it's a method through which eBPF developers can easily build, package, deploy, and run these gadgets or their eBPF programs. But most importantly, I like to think of it as a community. We're really bridging the gap between highly technical eBPF concepts and sort of the everyday developer who wants visibility into their Linux and Kubernetes system. So all that said, Inspektor Gadget is a way for the community to supercharge eBPF programs by making them easy for anyone to use, enriching the data that comes from the kernel so we can easily understand it in the context of higher level concepts like Kubernetes. And I'll get into how we do that and what that means. So in the previous slide, a few slides ago, we had a big question mark in the user space. And now you can see that we have Inspektor Gadget on that side. So like the previous slide, we do have eBPF programs. We're calling them gadgets. These are specially packaged eBPF programs that live inside OCI Images. And like the typical eBPF programs, the events are sent to an eBPF map, and they're filtered, and then where the magic of Inspektor Gadget comes into play is we filter the data, we enrich it by connecting it to those higher level concepts like containers and Kubernetes, like I mentioned earlier. And we do this user space processing and also allow you to export the data in the modes that you would like, and also share and distribute the data in many modes of use. So when, someone said magic on the word cloud, I really like that because we kind of say that Inspektor Gadget brings even more magic. We like supercharges eBPF, which is cool. I thought that like whoever said that, I really like that because it's like bringing even more magic to the existing magic that eBPF has. Cool, so I'm gonna dive into a little bit of the event enrichment and filtering piece. And we kind of set this out at the beginning, right? The problem is that eBPF gives low-level data, right? So what Inspektor Gadget does is we add that higher-level data. We give data around Kubernetes pods, containers, domain names, all of that sort of stuff. And we also filter the data. We want to make sure that you all as users are seeing the most important information that is relevant for your all's applications of eBPF. Cool. So this is a diagram of how it all works. You can see on the left-hand side, we have the eBPF program. There's a little bit of filtering that happens on the kernel side, and we have all the events that, like eBPF programs, even Inspektor Gadget, the gadgets are event-driven. It sends the data to the eBPF maps, and then in the user space, Inspektor Gadget does the enrichment of the data using the Kubernetes API server, container managers and runtimes, and other things to map the low-level data to higher-level Kubernetes concepts. Cool. So I'm now going to get into what is a gadget. We've been talking a lot about, oh, gadgets, this, gadgets, that, they're eBPF programs. What actually is a gadget? A gadget is an OCI image that is composed of 3 primary parts. The eBPF program is the bread and butter of what gives these gadgets their core functionality. It does the heavy lifting to get us the information that we need from the kernel. A gadget also consists of a YAML file that has metadata so that we can understand what's the point of this gadget, what's the purpose, what kind of information are we going to get from the gadget, how exactly is it used. And then there's the option for a wasm file for any post-processing that you would want to come after the magic, sort of the enrichment occurs using Inspektor Gadget. So if there's any post-processing that you want to do, we make sure that you have the ability to do that using an optional wasm module, which I think is great because everyone has their own needs of this data and they might want it formatted in a certain way. So gadget developers have the power to customize the gadgets in a way that they see best fit. Cool, so the idea really is that these gadgets can live in an OCI registry, like GitHub Container Registry, and that essentially acts as a marketplace for these supercharged eBPF programs that we're calling gadgets. So the idea is that we could have like a library of gadgets that live in the OCI registry, and we can build off of those, community members can build off of those gadgets, but maybe you pull the gadget down, you make some tweaks to it, maybe you alter it a little to meet your more specific specifications, and then you push it back to the OCI registry for someone else to use in a different way. So that's, when we talk about community, this is like kind of the mechanism through which we can share these gadgets with each other and build off of them and enhance them and tweak them a little bit to work together to build a library of eBPF supercharged programs that we're calling gadgets. And I wanted to shout out the Auras project as an open source CNCF project that we use for the image push, image pull functionality to get the gadgets to and from the OCI registry. So it was fun collaborating with them on that. So we talked a lot about eBPF, we've talked a lot about gadgets, but like in the anatomy of a gadget, how these gadgets work, but I want to actually talk about what are these actual gadgets, and I'll be getting into, the list of official gadgets and some sample gadgets, and we'll do a little demo later on as well. So I did want to give you guys the rundown on sort of what we're calling official gadgets. These are the gadgets that the Inspektor Gadget team has already written, and it sort of acts as like a base, but we're hoping, of course, that the library of gadgets will grow and grow and grow. So we have advised gadgets. So these gadgets collect data on the system and provide recommendations for configurations of the system. So the CComp profile and network policies gadgets, these are security configurations that are suggested by the gadget. These gadgets will suggest different configurations for the user. We also have audit. So audit gadgets are analyzing security profiles that might be blocking activity on the host, for example. So this CComp one tells if there's a certain CComp profile that's blocking system call activity from a certain process or container. There's also the profile set of gadgets. So this is profiling the performance of subsystems on the system. Snapshot, it's a point in time, so it provides the current status of the subsystem, for example, a list of processes that are running at a given point in time. Top is a gadget that collects information and prints a list of items that can be sorted based on a given criteria. I'll be demoing one of these. And then trace is a gadget that traces and prints system events continuously, and I'll be demoing one of those as well. For example, like when TCP packets are being dropped, it'll be able to print those types of system events. Here is a little bit of a deep dive into some of the some of the gadgets that I sort of gave you guys the categories before. Here's some of the actual gadgets. Trace DNS is one that provides information to help determine if DNS is impacting application performance. So it shows query success, response errors, latency, that sort of thing. Top block IO is used to visualize containers generating the most block device input and output. And then snapshot process, I kind of touched on that one earlier, prints a list of running processes. So if you have a Kubernetes pod, it'll also print the pod name, the container name, the process ID. Okay, we have another Menti poll if you guys want to play along. So it's the same one. I think I need to, let me see, I think I need to go to here and then click the next. Let me see, here we go. Yes. So it's the same, oh, I forgot to ask this one, sorry. Here we go. This is which type of gadget seems the most useful to you? So I listed the advise, audit, profile, snapshot, top, and trace, and maybe one resonates with you more than others. Would love to I'm curious to see which ones seem the most useful to you, and it should be the same code and everything. I appreciate you all playing along at home. It's fun to see the responses come in. Trace, okay, cool. We'll be demoing trace, one of the trace ones in a little bit. Cool. Yeah, that's awesome. Okay. Alrighty, back in business. Thanks, everyone. That was fun. Okay, so now that we know a little bit about eBPF, we know a little bit about Inspektor Gadget, I'm now going to give you guys some background information of how an Inspektor Gadget started. I didn't want to bury the lead, that's why I gave you guys the information that you wanted up front, and now I'll give you guys a little bit of history so that you know how it all started. So the project started in 2019. The team was really excited about eBPF and BCC tools, but really that higher level context was missing. You know, this is when Kubernetes was really coming onto the scene. It was a very, very important part of the cloud infrastructure, and really the team wanted to bring eBPF to Kubernetes. So initially the focus was really only on Kubernetes, but now not only do we support the, Kubernetes, but also it works with the Linux host directly, of course. Additionally, the gadgets that we have, initially the team started with making gadgets out of sort of the BCC tools, but they've expanded well beyond that. I mean, you guys saw the list of gadgets that's growing even more. So, and of course, we want the community to contribute as well and build gadgets that make sense to them. And through this whole process, the team discovered that that they had essentially built a framework, right? So instead of having just Inspektor Gadget be like this set of tools, the gadgets that, we would just throw over the fence, it more became a framework that anyone can write their own eBPF program and build their own gadget and sort of get the magic on top of the magic. So that's sort of where the team is at right now, transitioning from this built-in gadget to more of this framework for creating this community aspect of Inspektor Gadget. Cool, and why Inspektor Gadget? I hope it's clear right now that eBPF is extremely powerful, but it's hard. It's technically hard, and it's not necessarily intuitive. And once you have the data from the kernel, it's not necessarily immediately useful, right? We want to understand the system as a whole, and sometimes just having the granular kernel data is not enough. And there is a world in which you could piece this all together, right? You would probably need a lot of additional tooling, and it would be pretty fragmented. You'd need something to manage the eBPF programs, something to map this kernel level data to the higher level resources, Kubernetes, containers, all of that good stuff. Something else to do the enrichment in the user space, and then even something else to export the data. So the reality is Inspektor Gadget exists because we want to streamline that process, making the kernel data as useful as possible to everyone who wants visibility into the Linux and Kubernetes ecosystem. I want to share with you all a few examples of how Inspektor Gadget is being used today. Our friends at Armo created the open source project Kubescape, which is a container vulnerability scanning tool. So they used Inspektor Gadget to hook into different eBPF events specifically to understand which files are being opened in each of the workloads that are running a Kubernetes cluster. So that's kind of a cool application of Inspektor Gadget in sort of the security space. And I really like their logo, that little panda. I had to include that. Another application of Inspektor Gadget today is with MS Defenders for Containers. So the Defender for Containers team recently built a new sensor, and that sensor includes Inspektor Gadget to collect security events and generate insights in real-time threat detection alerts. So we are excited about that one as well. And I, of course, had to mention Amazon EKS. Amazon EKS users are leveraging Inspektor Gadget to inspect their Kubernetes environments on a day-to-day basis with eBPF and Inspektor Gadget, which is awesome. Alrighty, so how you can leverage Inspektor Gadget. There are many modes of operation when it comes to Inspektor Gadget. That's sort of the beauty of it, is that it can be used in a variety of contexts. So we can run the IG binary directly on the Linux host or inside a container. We also have the option to use Inspektor Gadget in a client-server setup. So Inspektor Gadget runs as a service inside the host, and we use a client called Gadget-CTL to control the service via an API call. And of course, I spoke quite a bit about Kubernetes. Inspektor Gadget is deployed via a daemon set to allow for standardization across the Kubernetes cluster. So Inspektor Gadget is deployed via the daemon set, and we use the kubectl gadget plugin to control the daemon set. And the one that I'm really excited about, this one's still a work in progress, is the Go library API. So the team is working really hard to finish up and build out the functionality for a Go library API, so that ideally an application could access the kernel just by using the Go library API. I feel like that's probably like the easiest way for one to use it. So I'm really excited about that one. Cool. So So we've been talking a lot about the data and that Inspektor Gadget maps it to high level concepts, but at the end of the day, you want to be able to export this data and use it in a way that you see best fit. So we have a few export options that the team is working on, and this is actually like one of the places that I would love to hear your all's feedback. Right now, the team is talking about like raw data. We provide you with a JSON file. You can do with that what you please. Prometheus, that would be, actually Prometheus is almost done. We're working towards a more efficient way of exporting the metrics to Prometheus, but Mauricio did a talk at KubeCon with the initial like baseline functionality in Chicago. And so that is basically done, but we're just trying to optimize it a bit. And then open telemetry, of course, this is a work in progress, but we want to support all of the good things that open telemetry does. And I felt like Alan's talk that he just did really emphasized the importance and the power of open telemetry, and I'm sure you all are also very familiar with it and its superpowers, so that's definitely a high priority item for the team. But like the data export options are so important because ultimately that's what the end user is going to want to, the way that they want to see the data is super important. So if you all have any feedback or anything on where you would like to see data exported to, I'd love to hear from you. Alrighty, demo time. So I'm going to take a second to set up the demo before actually diving in. We're going to be demoing Inspektor Gadget in the context of a Kubernetes cluster. I'm using AKS just because it was the easiest for me, but it'll work on EKS, GKE, your local cluster, whatever you want. I have to say that disclaimer. And I've already installed Inspektor Gadget on the cluster, and I've also deployed a couple applications onto the cluster to show you all the functionality of Inspektor Gadget and demonstrate sort of the data that comes from it. And so in this demo, we'll be showing trace DNS and then top TCP. So I think that's all I wanted to set up, and I think, oh, it is playing. Okay, great. So I just am showing the help command right now, gadget help, so you can see, it's playing, great, yeah. You can see the different commands that are available, and right now I'm going to be checking the version just to make sure I have the most up-to-date version of Inspektor Gadget installed on my cluster. And now I'm going to be using the trace DNS gadget to understand what is going on the cluster. I'm specifying in this command a pod that has my application on it, and you can see the data that is coming through using the trace DNS gadget. Essentially, on the right-hand side is sort of the data that you'll be interested in, but you can see that there's a wrong URL that is basically unable to be resolved, and then there's example.com that is showing no errors. So basically, if we have these URLs that are trying to be resolved, we can see that, oh, actually wrong URL.test is the one that's giving me a problem here, and the example.com is good to go. So this is a pretty common error people face. Like, we have this joke, it's like, it's always DNS. It's like a typo in the in the URL. It's an outdated URL, but sort of it's always DNS. So trace DNS. I mean, you guys also said trace was one of the more popular ones, right? So I should have paused here. Let me pause really quickly. Anyways, yeah, trace DNS is a really popular one because, like I was saying, it's always DNS. There's always something. So the next one that I sort of jumped the gun here, is top TCP. So I am getting all of the activity from the Kubernetes cluster using the top TCP gadget. And I'll play the video and you'll be able to see that in this top line, you can see that there's a ton of traffic being sent from pod 1 to pod 2. So pod 1 is generating a lot of traffic, and we want to understand what's going on here. They're Could be a network saturation issue or something similar to that, but in this case, we know where to look. You can see in the sent column, the pod 1 is sending a ton more traffic than any of the other sort of business as usual activity that's happening on the Kubernetes cluster. So it's ordering in descending order, so we're able to see the most pressing issues first, and it kind of is highlighting the large amount of activity that is happening in pod 1 as compared to the others. So that's a quick demo of trace DNS and top TCP, which I'm glad we did those, because it seemed like from our little poll, the trace one and even top seemed like people were interested in. Yeah, so sorry if it was small. I didn't really know like how it was going to show up on here, but these are screenshots of what you all just saw, just so you guys can see it static and not a video playing like crazy fast. Alrighty. So what's next? Looking ahead, I am excited to share some of what's next. We really want to support a declarative way to run gadgets. Like the CLI is a great way to interact. You could see, I could get a lot of information, but if there was a more streamlined approach that people could use Inspektor Gadget in a sort of proactive way, we really want to be able to support that through a configuration file. Additionally, I kind of hit on it earlier, we want to support many export options. I touched on the Golang API as well, and making sure it's good to go and has fully supports the image-based gadgets and the direction that we're heading in. Additionally, if you all use artifacthub.io, our gadgets are in there, which is really exciting to have like a centralized place where people can find the gadgets and learn more about Inspektor Gadget. And most importantly, the last two, I feel like the last two are like probably the most important, is we want to understand community priorities. What do you all want to see from Inspektor Gadget? How do you want to use it? Where do you want to use it? Where do you want the data to be able to be exported to? All of these things are really important things that require community feedback on, and we'd really love to hear from you. And then of course, documentation. I have to say, I joined the team late last year, and one of the things I was so impressed by was the documentation that we have on GitHub and our website. It's like, if you guys are interested, I really, really encourage you all to check it out, because I love how the documentation is coming together, and the team has worked really hard on that. So yeah, props to them. But a little call to action, if you would. I'd love for you all to think about how eBPF could be used to enhance the projects you're working on, understand what's going on in your system, and see if we have a gadget that could help you. And yeah, I think that's it. I have a Menti for questions too, if you guys want. I know sometimes raising your hand, and we'll take questions in the room too, but if you guys want to submit your questions through Menti, that's also an option, because I know it can sometimes be intimidating on the mic, but it's an option, and for people online too, but also in the room too. I just wanted to give it as an option for people, like, yeah, even the playing field for those who are watching on YouTube or whatever. If anyone has any questions, you're welcome to submit through the Menti poll or in the room. But yeah, thank you so much. It was great talking to you all.
I guess, yeah, there we go. Okay. So I came in just a tiny bit late. Is Inspektor Gadget a commercial product, or is it free to use?
Oh, it's completely open source. I want to emphasize that. It's a CNCF Sandbox project. The question for those online, I don't know if they can hear, I was told to like maybe request, it should be good. Great, okay. Yeah, it is a CNCF Sandbox project, totally open source. We want to hear from you. We want to make sure everyone is able to contribute, all that good stuff. So yeah, totally open source. We love that about it. Thank you.
Really interesting stuff. So the question I have is that, I mean, I'm looking at your GitHub.
Yeah.
So do I pull your code and install that in my Linux box, or how does that work? Is that because I mean I'm interested more in IG
Sure.
command line tool that you have,
Yep.
so that we can observe the applications from the Linux side of it. We don't really use that much Kubernetes, K8s and all that.
Yep.
So is that safe to do, or how does that?
Yes, definitely. You can definitely use the IG tool directly on the Linux host. Absolutely, you don't have to use it in the context of containers, and it is safe to use, definitely. I will say, like, the gadgets are signed. We use like a signature methodology to make sure that people feel comfortable using the gadgets, but we use the principle of least privilege as well to make sure we're only accessing the minimum amount necessary for the kernel, because it is the kernel. Like safety is important, right? And eBPF programs are safe to run because they run through the verifier, but that doesn't mean, they can change what's going on in there, right? It doesn't mean, they won't crash your kernel, but they can do other things, right? So it's a very valid question, and yeah, it is safe. We would hope so, but it's a valid concern, definitely. Yeah, thanks for asking that.
Thank you.
We have a question from Menti. How do I get started with eBPF? Love that. The BCC project has great introductory materials. I also have done a lot of learning through YouTube. Liz Rice is has a huge presence in the eBPF space, and I like watching her videos, and she has some good podcasts that she's on, and I think she recently wrote a book about, she has a couple books about eBPF too, so that's a good place to get started as well. Alrighty, thank you all. Thank you so much.